Linear equation are chosen independently from a randomly from a list of 100 consecutive integers that include 0. The probability that the resulting line has a positive slope and a negative y-intercept has a maximum value that can be expressed as k over 20,000. And the value of k. What does it mean, maximum value? Is the probability not just... What? Okay, so the resulting line has a positive slope and a negative y-intercept. So let's rearrange this into slope-intercept form. We get y is equal to negative a over b x plus c over b. So we want negative a over b to be as a positive slope to be greater than 0, c over b to be less than 0, or rearranging this, a over b to be less than 0, to be, yeah, less than 0. So both of these to be negative. So for a and b to be less than 0, that means that either a is equal to negative, okay, let's make a table with all the options. So this is our first table. If a is negative, if a is less than 0, then we have b is negative, b is positive, c is negative, c is positive, and here we have a is positive. We also have to take into account 0, because that is an option. B equals negative. Here, c is equal to negative. Here, c is equal to positive. Here, b is equal to negative. So, positive. So the only ones that work are where a and b are negative. So a is negative and b is negative does not work. It's like or. Negative y-intercept is a maximum. Okay, so I don't know why I shouldn't be using red. Maybe I'll use maroon. Or I'll use pink. So a over b is less than 0, so these two can't be the same. So this won't work, and then both a and b are positive won't work. And this won't work, this won't work. So c and b have to be also negative. C over b has to also be negative. So c and b have to be different. This one doesn't work, and this one doesn't work. So these are only two that work. So out of 100 consecutive... Oh, because we don't know what integers... Okay. So the maximum value of this... We want to find the maximum probability that A is positive, B is negative, or C is positive. Or A is negative, B is positive, C is negative. So we should have an equal amount of... So our four different things are A is positive, B is negative, C is positive, or A is negative, B is positive, C is negative. So to maximize this, we just need to maximize the amounts of positives and the amounts of negatives, because in total here we all have 3. So I think we should go from negative 50 to 49, so we're including 0. right? Because like let's say we go -5 to 4, that's 10, right? 4, 5, 4, 3, 2, 1, 4, 3, 2, 1, 4, 3, 2, 1, 0, -1, -2, -3, -4, -5. Okay, that's correct. Okay, so the probability so what needs to occur is that, let's say A is positive. Given that A is positive, which is a 49 out of 100 chance, times B is negative, which is a 50 out of 100 chance, times C is positive, which is a 49 out of 100 chance. This is also 49 out of 100 actually, because we can't have 0. It's a positive slope and a negative y-intercept, so C can't be 0, A can't be 0. Okay. It's the same thing for this one. So it's 49 of 100 times 49 of 100, 49 of 100, plus, I guess it's just 2 times that, because that's plus that, so 2 times that. So we're given 49 cubed, or I guess it'd be 7 to the 6 over 2 times 7 to the 6 over 100 cubed, which is the same thing as 7 to the 6 over 50 times 100 squared, which is, there's no way this is the correct answer, but because this has to be some decimal. Maybe let's create a general equation for the consecutive integers. So if we have, it's going to be 2 times something over 100. It's going to be 2 times something over 100, or 100's cubed. So if we just change the probability, it will be probability of a positive, negative, positive. So the probability of a positive squared negative plus negative squared positive. The number of integers that are this. We want to maximize this. So if we want to maximize this, positive squared negative plus negative squared positive, where positive and negative add up to 100 or 49, or add up to 100 or 99. Well, it has to add up to 99 because we're not, because 0 messes with it. So it's going to be like 2 things that add up to 99. So that means positive and negative are practically interchangeable because it doesn't really matter. So the maximum probability is going to work symmetrically. But positive squared negative plus negative squared positive. P squared n, it's really x squared y plus y squared n x, y squared x. How do we maximize that? Well, first off, we can take out 2 times Pn over P plus n over 100 cubed. So maximize the product of two numbers. We want to pick the closest ones together. To maximize this, it doesn't really matter because we know p plus n is 99. 99 over 100 cubed. So to maximize this, I think it's just 2 times pn, which is 40, it's just going to be 49 times 50 over 99 over 100, or times 99 over 100, right? No, because positive and negative, yeah. Since we have 100, it's gonna, how many positive and how many negative are there? There's gonna be, sorry about that, I got interrupted. So going back, let's say we have 100, let's just simplify it to 10 because it's just hard to think about that and I'm bad with this type of stuff. We have 10, we're gonna go negative 5 to 4, we have 1, 2, 3, 4, so we have 4 positive, negative 5, negative 4, 3, 2, 1, 5 negative. So 9 total, so yeah, here we're gonna have 49 times 50, discluding that 1 0, and just, so this is our max, so 2 times 49 times 50 over 100. Over 100 cubed. So 2 times 50 is 100, so that cancels out with one of these. So we have 49 times 50 times 99 over 100 squared. So we have 10,000 over, oh no, because we could take out one of the 100s. So 49 times 99 over 100. Ooh, did I mess this up somehow? Oh, because I already canceled out the 50. I have a feeling this shouldn't have 2 times. I think that's my issue. If I have 2 times then 50, so it's 100 cubed. So then I have, this changes up to 1/2, so I get 2 times 100 squared times over 49 times 99. This goes to 20,000. This is 49 times 99, which I think will be K, our answer. 49 times 99 is 49 times 99, 81, 360, 810, 3600, 1, 5, 1, this is going to be 412, 8, 1, 4, so 4, 8, 5, 1, let me make sure I did this correctly. This 9 times 4 is 360, 9 times 9 is 8, is 8100, or sorry, 810, and then 3600, 1, this is 14 plus 1 is 5, then we get 1 here, 4, 12, 18, yeah, so 4581, let me check, yeah, it is 4851, I got it right, that is very surprising, I didn't think I was going to get this one right, looking at this originally. Cool, thank you for watching, I'll see you guys tomorrow, bye.